All right, class. All right, let's try this again. Let's try again. Class.
Yes.
A little bit better. Class, class.
Yes.
Get your earbuds away so I know that you're actually listening. No, you're not. What's the other one? It's just like an earplug. That's just like being rude. Like just la 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 la. That's all it is. Okay. So put it away, please. Thank you. Yeah, that's nice. Don't look at me like that. Put it away. Yeah, someone's gonna end up with just one AirPod here in a minute. Anyway, all right. So what page are we?
29.
So 29 in our notas. 29 in our notes. So this is actually going to be easy. This is a lot of stuff that we've done previously, but we're doing it as an application of real world stuff. This is where a lot of the stuff comes in that you'll actually use in real life. So example 1 says the license plate is made up of 6 letters or digits. So start with this. 1, 2, 3, 4, 5, 6. The first 3 positions are letters, and the last 3 are digits. How many different license plate could be if repetition of both is allowed? So repetition, what does that mean if repetition is allowed? Yeah, I could just use that same one. I could have BBB 888, right? No? Okay. So I want different combinations now. First, how many letters in the English alphabet?
26.
How many? 26. How many letters in the Spanish alphabet? 30?
I think
Yeah,
counting that
I think counting AA and
the N with the
and then NA, yeah. So those ones, yeah. So that's why I specifically said English. Do they still count that?
I think so.
Like the double L as like an actual separate letter? Okay.
Yeah.
Anyway, so there's currently 26.
86.
So there's 26. Now, next one. So another letter. How many possible for the next letter?
25.
26.
Why 26? Am I allowed to repeat? It is allowed. So the next one's going to be, and my third letter is, yeah, 26 now, right? They're all 26 because the repetition is allowed. So again, I could have like BBB. All right, now the next 3 are numbers. So how many digits are there?
9.
Are you sure? What you got? 10? You said that with a question mark, so I'm getting kind of worried.
10 if you include 0.
Yep, there's 10 digits. A digit is a single number. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So 0 through 9 is 10 digits. Now the next one here, the next possible number, how many possible numbers am I going to have here? 10 again, because I'm allowed to repeat. And my last one?
10.
All right, multiply that out, please. Yes, big number.
This big number.
That big number. Give me digit by digit.
1, 7, 5, 7, 6, 0.
17,576,000. Okay, that's a lot of possibilities, right? Okay, and that's only 6 digits. I believe Arizona licenses are 7. Yeah, I think there's 7, and they could be alphanumeric. So they could be digits or numbers all the way across. So that's going to list even more possibilities. Now, I want you people to try it using same steps. Next semester, you plan on taking 4 classes: college algebra, English, recreational sports, and chemistry. You talked about to your counselor and found that 3 sections of college algebra, 8 sections of English, and 6 sections of rec sports, and 4 sections of chemistry you could pick from. How many different 4-class schedules are possible? Do it. Do it. Thank you. No, thank you. Do it. Start off the same way I started off that last problem. All right. How many? All right, let's start off. How many dashes did I put? How many lines? 4. So I'm going to start with that, right?
Yes, sir.
1, 2, 3, 4. 4. In the first category, how many am I going to put in the first category? 3. Very good. Second category. Third category.
6.
And my last one?
4.
Very good. So now we multiply all those together.
576.
What is it?
576.
576. Different class, different classes, the different combinations. Yeah. And if I were you, always take your math first thing in the morning. You don't want the afternoon math class. So when you go to college, afternoon math class, you're already done. Your brain is burnt out. It's rough. First thing in the morning, you got to learn how to become a morning person, though. You got to have that be your first class. Highly recommend it if you're going to college. All right, I've been teaching college for over a decade, so trust me, I know. Yes. All right, example 2. At Old Navy, a supply of solid color t-shirts have just been received. The t-shirts come in the following colors: green, blue, white, yellow, and red. Billy, the manager, decided to display one of each color t-shirt in a row on a shelf. All right, first, how many do I have here?
5.
I have 5, right? Okay, so let's start with 5 dashes. 1, 2, 3, 4, 5. How many different possibilities do I have for the first one? Huh? Are any shirts on this shelf yet? No. How many different possibilities do I have there?
0.
I have 5.
Oh.
I have 5 different color shirts, right? Okay, right here. 1, 2, 3, 4, and 5. 5 different colors. So as I'm putting this in order, I got 5 different colors here. Now, what's next? How many different colors do I have for the second one?
4.
Why 4?
Because I have t-shirt.
I already used one, right?
Yeah.
I already used one. And so there's 4 left for this one over here, right?
And then it's gonna go
And then it's going to go
2 to 3.
3, 2, and it's always just that last one, no matter what. So whatever this one is, you have to just throw the last one down there. Multiply.
120.
120 different combinations for these shirts. Yeah, they think about stuff like this at Old Navy. They had enough better to do. If he wants to place a blue t-shirt in the middle, how many ways can he arrange the t-shirts? Okay, so let's start with my shirts again. 2, 3, 4, and 5. So I'm going to put a blue in the middle, right? Just So blue one's in the middle. I'm going to put my first shirt down. How many different ones do I have to choose from for my first one?
4.
4, because the blue one's already down there, right?
Yes, sir.
There's 4 there. What about the next one?
3. 2.
And 1, because that's what's left. So that's one way to actually do this, and just multiply the numbers out. Because the blue one's already been used, so it's 4 times 3 times 2 times 1, which is 24. Wow, that seriously limited it just by taking out one of those, right?
Yes, sir.
Is this making sense? I'm hoping. It's not nonsense, right?
No.
It's all sense. Last one. If Billy wants a white t-shirt to be first and blue to be last, then how many ways can we arrange it? So 1, 2, 3, 4, 5. So white shirt's first, blue shirt last, and color combination in the middle. So how many shirts are left for this one to put down?
24.
Very good. There's 3. What goes next? 2, and there we go. Multiply those together and I get... Woo! Está muy fácil. Es muy, muy fácil. Right, Candy?
Huh?
Muy fácil.
Maybe.
All right, let's go ahead, take a look, and you are going to try this next one. All right, let's see what we got. So you have 8 books to choose from, only put 4 on a shelf. How many ways can you arrange the 4 books? Okay, so let's take a look. So how many dashes do I start off with? 4, because only 4 of these are going on the shelf. Now, first one, how many do I have to choose from there?
4.
Nope,
8.
8. There's 8 books, right? Not all of them are going to go on the shelf. So there's 8 to choose from. And once I put one of them down, how many do I have to choose from next? 7. Then 6. Then, very good.
1,608.
What is it?
1,608.
1680?
Yeah.
There we go. Is this making sense, hopefully? Hopefully. All right. Now, if the 2 books, if 2 of the books must be in the arrangement, how many arrangements can be made now? So let's look at our dashes. So I have to have on my shelf, I have to have Lord of the Rings. And I have to have Hobbit. Those books go together. You have to put them there. And if you only have 4 spaces, you're not going to put the Harry Potter series, right? Because you can't put all 7 books if there's only 4 slots. Okay, so yeah, you got to be careful about that. The only one that I might actually go that you don't need to actually do all the rest of them, okay, any of the series, okay, the series of Fortunate Events, so only the first 3 books, okay, those are the only ones that I would actually consider only partial, because all the rest of them are weird. Yeah, those are too weird. Anyway, so if those two books from my collection have to be on the shelf, how many other books do I have to
6,
choose
5.
from? I have what?
6, 5,
And
5,
6 and 5. There we go, 6 and 5. So how many do I have left? 30 different combinations. Because, you know, you gotta have their autographed edition of The Hobbit. Right? Okay. Example 3. Password used to gain access to a computer account is to consist of 2 lowercase letters followed by 4 digits. Determine how many different passwords are possible if repetition of letters and digits are permitted. Now, when we're talking about passwords, there's something called case sensitive, because you have to have some uppercase and you have to have some lowercase, right? That's what case sensitive. So instead of having just 26 letters in the alphabet, you will have 52, because you have a capital A and a lowercase a. So that's the reason why. So now we have 2 letters, 1, 2, and 4 digits, 1, 2, 3, 4. So for my first one here, how many possible do I have there?
2.
No. The first letter,
Oh, 1. No, 52.
26.
26.
Oh.
So this one right here, because it says,
I got confused because it said
I know, but I wanted to say it because when you're talking about letters, and case sensitive is important. So if it's possible to have an uppercase and a lowercase, then you have to include both. But right here it says only lowercase. So how many lowercase letters are there? 26. There we go. And
You can repeat.
yes, you can. You could repeat that. So the next number is,
26.
now it is 4 digits. How many digits do we have? 10 digits. Can I repeat those digits? 10, 10, and 10. All right, what do we get?
I don't know how to do that.
26 times 26
No,
times.
like the
Oh, give me digit by digit.
6, 7, 6, 0, 0, 0.
Wait, wrong spot. That's 6,760,000 different combinations. That's a lot. But just so you know, just modern day computers could crack that in under a minute. So that's the reason why when you do passwords, you have to have case sensitive. So that means upper and lower case, and you have combinations of numbers, letters, and characters, which would be like exclamation, @ sign, any of those weird symbols. So those are necessary. Okay, so this next one says repetition of letters and digits is not permitted. Go ahead, Candy, go ahead.
So 5, you have to put like 5 lines, right?
3, 4, 5, 6.
So you're gonna put 26 and then 25
25, why?
because you cannot repeat.
Can't repeat the previous one, very good.
You're gonna put 10, 9, 8, 7.
Very good, good job. All right, put it in your calculadora. And final result,
3, 2, 7.
3 what?
2,
3, 2, 7, 6,
0, 0,
3, 0.
There you go.
7, 7, 7, 0.
So that means 3,276,000 different combinations. Now, just by not letting repetition happen, that's like half of it right there. That's a lot that you just took away different possibilities. Now this next one is kind of interesting. So I'm going to do a couple things here. So first two, I'll erase this here in a moment. First letter must be a vowel. Okay, English letters. What are my vowels? A, E, I, O, U. Going? We're going with 5. So there's going to be 5 here. Now, the next letter, first letter must be a vowel, and the first digit cannot be 0. And repetition of letters and digits is not permitted. So for the next letter, how many possible do I have for the next letter?
21.
I heard 4 and I heard 21. I don't like either answer. 26? It can't be 26. Can't. It would be 25. Why is it 25?
Well, you take one already.
I just used one of the vowels, right? We just used one of the vowels for our first place value, but I can't have it over here. So I'm only eliminating one of those out of my 26 letters. So that's 25 now, because one of the vowels was used over here. And it says the first digit cannot be a 0. So right here, it cannot be a 0, so watch this. So that's going to be 9. Okay?
Why?
First digit cannot be 0. So here's the list of numbers, right? So I crossed out the 0. So how many's left? Okay? So now watch this. Nope. Watch this. And repetition of letters and digits is not permitted. Okay, so the first one could not be a 0. Let's say, for instance, I'm just going to pick any number. So let's say it was a 4. So I can't repeat the 4, can I? I can't repeat the 4. So for this next place right here, how many numbers, how many digits do I have?
9.
I have 9 here now, right? Because I took away the number 4, but I also added back the 0, didn't I? So that's why that's 9. Because on my first one, I couldn't have 0. So there was only 9 digits there. But now on this one here, okay, I added the 0, but I took away whatever it was previously. All right, so now if it can't repeat, how many digits are left?
8.
8.
And 7.
So right here, so there's 8 left, and then do it again, and that's going to be 7. There we go. I just crossed out some numbers at random to see how many we'd have. Does that make sense?
Yeah.
So making a list of your numbers or digits is hopefully is helpful. So we multiply that out. What do we got?
567.
5, 6, 7, 0, 0, 0, like that? Okay. Not too bad. All right. So now this next one is going to be kind of interesting. So it's the same type of thing, but you're going to want to have a list of numbers to try to counteract these ones. So it says, it says, in the original plan for area codes in 1945, the first digit could be any number from 2 through 9 inclusive. So I could have 2 through 9. What numbers can I not have?
1 and 0.
Can't have 1 and 0. The second digit is either 0 or 1. Third digit could be any number except 0. With this plan, how many different area codes were possible?
4.
Try it. It's an area code. It's the first 3 digits on your phone number. I got hoes in different area codes. Okay. Get to work. Do it. Do it. Do it. No.
Can I have it?
All right, let's see. So we got different possibilities. So now, watch this. I'm gonna do it slightly different. So I'm gonna move over here. So I'm gonna do my 3, 1, 2, and 3. So I'm gonna list my possibilities. So how many possibilities do I have for my first number, my first digit? So it starts at where? 2, 3, 4, 5, 6, 7, 8, and 9, right? That's my different number of combinations there. What about the second digit? What am I allowed to use for my second digit? 0 and 1, and bless you, I think. Now, for my last digit is going to be 1 through 9. So no 0. So 1, 2, 3, 4, 5, 6, 7, 8. Now, we could just count this up. So this is another way to do these problems. I like doing this only with numeric because the alphabetic ones are kind of a pain, right? There's a lot of them. So we have how many different possibilities on this first one? 8. Next one there is? And last one is? Multiply all those together, we get? Of 144 different area codes. Does that make sense? All right. So, I think that's it for this set of notes. Is there anything else? No? Nope. So, this is what you're going to do. You're going to like, share, and subscribe, hit that notification button, and you know what? Even better. Even better. Okay. Promo code.
How much off?
10% off.
NFTs?
Promo code, 10% off. I need to pass. All right. I'll see you guys. All right.